On this video, we're going to cover how to graph quadratic equations when you have when you have all the terms, your A, your B, and your C. So let's review here where A, B, and C are found. So if you recall back to the standard form of quadratics, this could be your A, x squared, your B, x, plus your C, and A, B, and C will be numbers. So let's go ahead and identify those numbers in the problem that we have here. So if you notice here, the A doesn't appear in our problem, which means that it's 1. It's an implied 1 there. So it's going to be that term before, that number before the x squared. Your B is 6 in this problem, and C, which is your constant, is going to be 5. So we're going to be using these three values to help us find points so that we can graph our parabola. So C should be 5 here. The first thing we're going to do here, and we covered that in the previous video, is we're going to find the vertex. Since your vertex is a point, we need the x coordinate and we also need the y coordinate. So let's go ahead and start with the x coordinate because we need the x to find the y. So the x coordinate, we're always going to use this formula here. So you should be familiar. It should look familiar to you already. It's a fraction, so it's x equals negative b on top of the fraction, and the bottom is going to be 2 times a. And we already identified the values that we're going to plug in for your b and for your a. So our b was positive 6 when you plug it in because the formula has a negative. It's always the opposite. And the bottom is 2 times 1 since your a is 1. We simplify the bottom, we get 2, divide, and we get negative 3. So our x coordinate of the vertex is going to be negative 3. So we already have half of the vertex already. And we're going to use that negative 3 so that we can find the y coordinate. So on the side, let's go ahead and do the work for the y coordinate here. So finding the y coordinate is just simply plugging in your value for x and your equation. And f of x and y is the same thing. So I know that on our problem it's f of x and I wrote y here, but it's the same thing. It's just a different way to write it, just notation. So everywhere I see x in my problem, I'm going to substitute it for parentheses because we're going to plug in negative 3 there since our x equals negative 3. So everywhere I see x here, I'm going to go ahead and just write parentheses. And I like to set it up first. So I'm just going to put parentheses everywhere I see x, copy everything exactly the same, including the exponents. So notice how the only thing that's changing from our problem to what I'm writing right now is we don't have an x, we have parentheses instead. So inside that parentheses, we always plug in the x coordinate that we get. Let's go ahead and solve the exponents. Negative 3 to the second power just means negative 3 times negative 3, which is 9. The 6 and the negative 3 here, we multiply and we get negative 18. Bring down the plus 5. You should always check that the first number and the second number the first number is half of the second number and they have opposite signs. So since this is always half of it, it's always going to be the first number, so you're always going to subtract. You get negative 9 and then bring down the plus 5, so we get negative 4 for the for the y coordinate. So now we have a vertex. So we have 1 point so far of the parabola, which is actually the most important point, the vertex, because it's going to determine what your highest or your lowest point is in the parabola. So our a was negative 1, so since a is positive, that means that the parabola is going to open up. So that vertex that we found, the negative 3, negative 4, will be the min, will be the lowest point on our parabola, since the parabola is going to open up. The second part of the equation is asking for the y-intercept. So that's the second point that we're going to have to plot in our parabola here. So the y-intercept is actually found fairly easy. It's in your equation already. It's whatever the c is. So your x-coordinate is always 0, and then the y-coordinate is just whatever your c is. So now we have 2 points so far. We're going to use another tool that we have already to find that third point so that we can draw our u. So let me write the points right here so I don't have to be scrolling up and down. So our vertex, which was that, and our y-intercept, which was the 0, 5. And then we're going to go ahead and set up our grid so that we can graph here. So let me draw our y-axis first, which is that vertical line. And because we have like an equal amount of negative y values and positive y values, I'm going to put the x-axis in the middle. So I know I need to go to at least positive 5 on top, and then the bottom should be the lowest negative 4. And it doesn't seem like I'm going to need positive x coordinates to plot what I have, so I'm only going to include the negative x coordinates. So your x is that horizontal line. And just for the sake of it, let's include these values here on the y-axis. Okay, so let me start with the vertex, which is our lowest point since the parabola is going to open up. It's going to be that green point that you see there. And our y-intercept, I'm going to put it in red. So let me draw your axis of symmetry so it can help us find the rest of the other point that we need. So that axis of symmetry is that line that I'm drawing in pink, which cuts the parabola in half. So it always goes through the vertex. So just keep that in mind. It cuts the parabola in half into two symmetric sides. So our equation for it is x equals -3. It's whatever that x value that it goes through. So our y-intercept is 3 units to the right of the axis of symmetry. So that means that 3 units to the left, we have another point. And that's how we get the other third point that we need so we can draw our parabola. So just always count how far your y-intercept is from your axis of symmetry so that you can know how to get that third point on the other side. So that you can draw your u, which is your parabola.